Yeah, Lee's asked us to come say a few words about the project we're working on. I think it's a really great project. I'm really happy to be involved in the project. And you'll notice the title here, Innovations in Engineering Surveying. A little bit about myself, the presenters this morning. So my name's David Mayers, and also co-presenting Matthew Monk. So you'll notice the title here, I'm a surveyor, proud to be a surveyor, and definitely not a civil engineer. So I work for the joint venture, so part of the permanent team. And as Lee said, you might remember my speech from the NSRU project in 2014. That team that delivered that project in 2014 were also a co-winner of a EC award in 2014. So I was proud to lead them.
Okay, thanks. So in contrast to Dave, I'm a civil engineer, so not a surveyor, but working on a surveying project. So I'm actually doing some contract work, just helping the project out. So I did previously work for 12D UK, but now I'm back in Australia, helping people on some of these jobs. So now we'll give a bit of a project overview. What's NorthConnex? It's a motorway tunnel. It joins the M2 to the M1 and gets around our notorious Pennant Hills Road. Two key components, a tunnel, mainly a tunnel project, and also a separate project, an M2 integration project. It is Australia's longest and deepest tunnel, longer than all the Eastern Distributor, the M5 and the Cross City combined. So, who is delivering NorthConnex? We have the state and federal government. We have RMS, the State Road Authority, Transurban, who are the ultimate client, who have proposed this project. And we also have a joint venture between Lend-Lease and Boyes Construction, the contractors.
One thing to notice about this slide is the NorthConnex project, which is in Sydney's northwest. It joins up the orbital network, so you can see it's a vital link in the road network. A few fast facts about the project. It's around about 16 kilometres in mainline excavation. We have 4 ramps in total, around about 4 kilometres in length. Quite a few cross passages, tunnels in their own right. And 4 shafts, total of 210 metres deep, the deepest of which is just shy of 100 metres. As you can see, 2.25 million cubic metres of excavation. It's a lot of dirt. We've got 19 road headers, which will be working concurrently at one time, and that's a record for the country. Looking at the basic scheme of how we hope to accomplish this, as far as tunnelling goes, we've got 4 main sites, each of which we hope to launch 4 road headers. So you can see we've got a site to the north, a main site to the north, a main site to the south, and 2 sites in the middle. And here's a picture of a road header. They're pretty impressive machines, I think you'll agree.
Okay, thanks Dave. I'll now talk about some of the specific data management issues and how we solve those. So challenges, just to give you an idea about the size of the project. Not just the volume of it, it's the frequency of it. So we have up to 19 concurrent headings. Like we said in the intro, never before been done in Australia on this scale. That means approximately 4,000 to 5,000 cuts. Okay, so a cut might be a few metres. You cut, then do something, and then you cut again the next day usually, or the next shift. We are collecting approximately 5 to 10 survey tasks per surveyor per day, and we have about 20 to 30 surveyors. Often running 24/7, so there's no let up, there's no weekends. This data's coming in all the time. We are adopting the MS50 to scan our tunnels, and we did a quick back-of-the-envelope calculation. We're looking at about 100 million scan points per lining. So we have at least 3 linings, so that's roughly 250 million points for the entire scan of the entire project. We have approximately 300,000 bolts to install, and of course we have to survey those and report those as conforming to the design. We also have conformance of the tunnel itself. These have to be at 1 metre intervals, and that equates to roughly 100,000 plots. Okay, a lot of data. The previous techniques used in tunnels, just in general construction projects, are highly manual. Data is often unstructured, poorly managed. It's the last thing a surveyor does. Old habits and sometimes a bit of an outdated data culture. Wait for a rainy day to do all this. And there's the need to work in an offline and an online mode. So we have this concept of a central data model. Okay, it's a fairly old concept. It's gone by various names. The skirt guys talked about, I can't remember what they called it, but the same sort of concept, centralising their data. I'd say it's probably rarely used on projects of this size, or if it is used, it may not be used to its full extent. So we have all the data is centralised. Design and historical data is sent out to field surveyors or to others. Our survey or new data is collected from the field. It becomes our one source of truth, and particular for our surveying function on this project, it becomes a live as-built model. Data received from the field, once it's processed, approved and goes through the import process, then becomes part of the data we share back out. So all the surveyors are collecting and getting that as-built data of the project. So centralised, it's controlled, it's backed up, importantly, it's tracked, it has inputs, outputs, and it also has revisions thanks to Synergy. So here's an example, just a quick diagram of the various inputs we might have on this project. So not just field work, but design, utilities, tunnels, survey controls, and then we're pushing these out to surveyors, managers, other groups. So how do we collect this data? Okay, we need to standardise and automate this. It needs to happen offline or online. And so up until now, most of our focus has been on collecting the field work itself. That's the most crucial part of our data. But now we're actually starting to focus on all the other bits of data, plots, reports, and so on. We will eventually encompass all data. Okay? We hope to collect it all, whether we use it or not, yet to be decided, but we hope to collect it all. So once we've got that data, how do we distribute it? We are heavily reliant on sharing. Sharing is great. It's read-only, it's a fixed location, and we can use subscriptions to master share files to make it nice and easy. We use non-synergy sharing because we have to allow that to work offline in that disconnected environment. And one of the particular ways we've made this easier is we've developed a custom macro that's, again, tablet touch friendly. It's dynamically built from a configuration file, and it uses the concept of subscription presets. So here we have this panel, okay? So the user doesn't have to browse for these master share files, do a right click, which is hard on a tablet. They simply bring up this panel, put the tick box next to the data they want, hit process, and they receive it. They subscribe to those data, okay? Any one of those tick boxes is a preset, okay? And it could be one master share file, it could be many. Any of the greyed out ones mean they simply haven't downloaded that data yet. So it actually checks that and gives them a cue that they might need to download the latest data. It also allows them to list all the files. Again, they don't have to browse. They just have to tick the boxes, hit process. Okay? And that's a lot easier to use on a tablet and means they get the data that they need very quickly. So, file synchronization. So we have files coming in, files going out. So how do we manage all of this? We initially tried some of the third-party sync software that Richard alluded to, and like he mentioned, we had some problems. It didn't really scale that well, there are a few usability issues, and it was pretty manual. So we discussed these problems with 12D and said, hey guys, what can you do? And of course, we said we need something simple and reliable. Again, offline, online, it shouldn't matter. So, of course, 12D, being the great guys they are, came and developed the custom solution, okay? The data sync that Richard was talking about. So the official title for now is 12D Synergy Synchronisation Tool. It's a bit of a mouthful, so we call it Synergy. Okay. You can use that, Richard. Okay. So the 12D Synergy Sync tool, Richard will go into more detail in one of the sessions. It is based on the 12D Synergy client. It's really just an extension to it. Importantly for our surveyors, it doesn't require any special knowledge or training. They don't need to ever open the client. It's all run from the system tray, one little icon. It is centrally managed, so we in the office can push data out and receive it. It's all task-based, so you get the benefits of those tasks. Emails, you can track the progress of when things have downloaded. Very critical to ensure that the data they're using is current and up to date. It does upload and download, and it does this either manually, so they can still do it on demand, or we can force it onto them in a scheduled or at a particular interval. And again, offline, online. So it automatically detects when it's got a network, connect to the server, and it'll upload or download.
We are syncing.
Hello? This is the German Coast Guard.
We are syncing. We're syncing.
What are you thinking about?
Okay, so that's Dave gets a giggle out of that every time. So that's all this talk about syncing. He pretends he's a German Coast Guard. So just some screenshots about this sync tool. Here it is. Here's a task, and you can see I've assigned this to everyone, and so it gets populated using the group roles in Synergy. We can track who's downloaded, who hasn't. There's our Synergy sync tool, just sitting in the system tray, one icon. That's what the user's presented with when they have a download task, and that description is populated by the user or the manager who creates the task. They do get the chance to either download it or not. Not downloading it doesn't really not download, it just postpones it, so it's a bit of a nagging, keep downloading this data. So, how do we track all this data that's coming in and out and all over the place? Okay, so we have field work that's processed for review. Okay, the approval status is tracked in Synergy using that macro that we talked about. We do actually have a full audit trail on the 12D model data. So this is talking about the rich data using attributes. Okay, we had attributes at each stage, who did what, when it was done, the comments attached, time, computer, all sorts of things. And that means that every single point in our CDM can be traced back to the user, time, and a particular file of when that survey was done. Okay? And that helps keeps the auditors happy and satisfies our QA requirements. So here's just some screenshots again. Like I said, our model is live. So as files are coming in, they're updating this as we go. So we don't actually process this at all, it just sits there. And this is the data that also goes back out to surveyors. Here's a nice one. On the left, we have our as-built shaft and the tunnel. And on the right is the actual design model of that. Okay, so you can see they're very closely matched, as you'd hope. So, what are some of the successes we've had with 12D Mol and 12D Synergy? We've been able to automate the data submission. Surveyors really don't have to think about it or worry about it. We do it automatically for them. Okay? It works offline or online. It just queues it up. When they're online, it submits it. We're getting structured and usable data, okay? Which is important. All survey staff are using the same base data. We don't have different versions or different copies of data. It's all the one data set that they're all using. The data is current, controlled, and it's live. It's a live model.